Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Today we will discuss the oxidation state or oxidation number and a rule for assigning the oxidation state. So what is oxidation state or oxidation number? So the oxidation number or oxidation state can be defined as the apparent charge on the atom of an element in a molecule or an ion is called oxidation state or oxidation number. Oxidation number is the apparent charge on the atom. So it may be positive or negative or zero. Look here. What is the apparent charge on sodium? The apparent charge on sodium is +1. So the oxidation number of sodium is +1. It is positive. Similarly, the oxidation state of magnesium is +2 because its apparent charge is +2. And the oxidation number of chlorine is -1. Oxidation number of oxygen is -2. And if there is no apparent charge, so it means that their oxidation state will be 0. We know that all the atoms are electrically neutral. Why? Because the number of protons are the same as the number of electrons. So in pre-state, its oxidation number are 0. And when they gain or lost electron, either they will become positively charged or negatively charged. Now we are discussing the rules for assigning the oxidation states. The rules for assigning oxidation number or oxidation state. First rule, the oxidation number of all the element in the pre-state is 0. The element which exist in the free state, they are electrically neutral, so their oxidation number is 0. For example, sodium. Its oxidation number is 0. Magnesium in pre-state oxidation number is 0. Calcium in pre-state oxidation number is 0. And potassium oxidation number is 0 because they are in pre-state, and those elements which exist in the pre-state, all of them have 0 oxidation number or oxidation state. Second rule. The oxidation number of an ion consisting of a single element is the charge on it. Those ions which are made of a single element, their oxidation number will be the apparent charge of that ions. For example, potassium has +1 charge. What will be the oxidation number of potassium? Their apparent charge is its oxidation number. +1 is the oxidation number of potassium. What is the apparent charge on calcium? The apparent charge on calcium is +2. Therefore, the oxidation number of calcium is +2. Similarly, hydrogen has +1 oxidation number. Chlorine has -1 oxidation number. Bromine has -1 oxidation number. And oxygen has -2 oxidation number. These are symbol ions because they consist of a single atom. So therefore, their charge is the oxidation number. Now, another rule. The oxidation number of hydrogen is +1 in all of the compound. In all the compound, the oxidation number of hydrogen is +1. But except in metal hydrides, their oxidation number will be -1. For example, in HCl, we know chlorine is the high electronegative element. So the chlorine will carry a negative charge and the hydrogen will have positive charge. Similarly, in H2O, oxygen is highest electronegative, their oxidation number is -2. So hydrogen has oxidation number +1. But in metal hydrides, why in metal hydrides? Because the electronegativity of hydrogen is more than the metals. Therefore, hydrogen will take the electron from the metal and hydrogen will become negatively charged. So the oxidation number of hydrogen in metal hydride is -1, but in all the other compound the oxidation number of hydrogen is +1. NaH, sodium will have +1 oxidation state, +1. Calcium has +2 oxidation state and the hydrogen has -1. Another rule, the oxidation number of oxygen is -2. In the normal oxide, the oxidation number of oxygen is -2. But in peroxide, the oxidation number of oxygen is -1. For example, what are normal oxide? Normal oxide, misal H2O. For example, H2O is normal oxide. The oxidation number of oxygen is -2. Similarly, in Na2O, sodium oxide, the oxidation number of oxygen is -2. But in peroxide, in which one oxygen is more than the normal oxide, their oxidation number will be -1. Hydrogen peroxide, sodium peroxide, the oxidation number of oxygen is -1. But in OF2, the oxidation number of oxygen is +2. Why? Oxygen has +2 oxidation state in OF2. We know the highest electronegative element in the periodic table is fluorine, and it belongs to 7 group, so the oxidation number of fluorine is -1. Now, oxygen will lost electron into the fluorine. So the fluorine will take the electron normally. Therefore, the oxidation number of fluorine in OF2 is -1 and the oxidation number of oxygen is +2 because fluorine will take the electron from the oxygen. Another rule, in neutral molecule, the algebraic sum of the oxidation number of all the element is 0. The molecule which are neutral. So the algebraic sum of the oxidation number of all the element will be 0. Look here, H2O. We know the oxidation number of hydrogen is +1 and the oxidation number of oxygen is -2. But there are 2 hydrogen, so the oxidation number of 2 hydrogen will be +2. And the oxidation number of 1 oxygen is -2. So +2 -2 is equal to 0. So this is a neutral molecule and the algebraic sum of the oxidation number of hydrogen and oxygen is 0. Therefore, the molecule is neutral. HCl. We know the oxidation number of hydrogen is +1 and the oxidation number of fluorine is -1. So +1 -1 is equal to 0. So this is a neutral molecule because the oxidation number of the oxidation number when we add +1 -1 is 0. Look to nitric acids. The oxidation number of hydrogen is +1 and the oxidation number of nitrogen is +5. So +5 +1 is equal to +6 and the oxidation number of 1 oxygen is -2. So the oxidation number of 3 oxygen will be -6. So +6 -6 is equal to 0. So the algebraic sum of the oxidation number of hydrogen, nitrogen and oxygen is 0. Therefore, this molecule is neutral. Another rule. In iron, the algebraic sum of the oxidation number of the atom is equal to the charge on it. In iron, the apparent charge is the algebraic sum of the oxidation number of the atom. For example, the oxidation number of 1 oxygen is -2. How many oxygen are there in sulfate? There are 4 oxygen. So the oxidation number of 4 oxygen will be -8. And the oxidation number of sulfur is +6. So +6 -8 is equal to -2. So the apparent charge is the algebraic sum of the oxidation number of sulfur and oxygen. In nitrate, the oxidation number of 3 oxygen is -6 and the oxidation number of nitrogen is +5. So +5 minus 6 is equal to -1. So -1 is the apparent charge, which is the algebraic sum of the oxidation number of nitrogen and oxygen. Now look to the carbonate. Again, the oxidation number of 4 oxygen is -8, and the oxidation number of carbon. Here the oxidation number of carbon, this is carbonate -3. So the oxidation number of 3 oxygen is -6, and the oxidation number of carbon is +4. So +4 minus 6 is equal to -2. So this is the apparent charge, which is the algebraic sum of the carbon and oxygen oxidations numbers. Another rule, the oxidation number of first A group, second A group, and third A group are normally +1, +2, and +3 respectively. Group first have 1 valence electron, so they can lose 1 electron, and their oxidation number will be +1. Group 2 have 2 valence electrons, so they can lose 2 electron, and their oxidation number will be +2. Group 3 have 3 valence electrons, so they can easily lose the 3 electron, and they will become +3 charge respectively. Similarly, the oxidation number of halogen, group 7 is -1, because group 7 have 7 valence electron, and they can accommodate a maximum of 8 electron in its valence shell. So they required 1 electron, so they can take 1 electron, and their oxidation state will be -1 normally. In any substance, the more electronegative atom has negative oxidation number. In any substance, the more electronegative atom has negative oxidation number, and the less electronegative atom has positive oxidation number. So these were all about the oxidation state and oxidation number. Now, if you have any questions, so you can ask. Okay, wish you best of luck.